If you have an equation that's a function, sometimes you'll see it written in this notation with f parentheses x close parentheses. The way we read that is f of x, and that can mean the same thing as y. So we have this equation y equals 2x plus 2. Since this is a function, we can use f of x equal to 2x plus 2. And what we can do with that is if we want to find out what's going on at a specific x value, we can substitute that x value in for x here. For example, if I want to find f of 1, it would say, okay, f of 1 would be 2 times 1 plus 2. Anywhere I see x, I'm going to put that 1 because it says f of 1. So let's look at some examples. We've got the function f of x equals 3x plus 4, and we have these three different things that we need to find. The first one says f of 4. So anywhere I see x in my function, I'm going to put 4. So starting off, we've got 3 times 4 plus 4, and now we're just going to evaluate. So doing PEMDAS, we're going to multiply these first before we add. So 3 times 4 is 12 plus 4, which is 16, and that is the value of our function at an x value of 4. Let's look at f of 1/2. So we've got 3 times 1/2 plus 4. You can write 3 times 1/2 as 3 over 2 plus 4, or if you prefer to use a decimal, you can write it as 1.5 plus 4. If we're sticking with the fraction theme, then 3/2 plus 4, well, 4 is just 8 over 2, so then we have 3 plus 8, which is 11 over 2. Or if you want to stick with the decimal, 1.5 plus 4 leaves us with 5.5. Both of those mean the same thing. It just would say leave it as a fraction if it wanted this specific answer, leave it as a decimal if it wanted this one. If it doesn't say, you can do either one. Finally, it says f of a plus 5. That still means anywhere that I see x, I'm going to put a plus 5. When I do that, I'm going to put it in parentheses because I want to make sure that I account for that entire term. So we've got 3 times the quantity a plus 5, and then plus 4. Now with this, we can't evaluate because we don't have a value of a, so we're going to just simplify it. So I'm going to start by distributing the 3 to the a and the 5. So now we have 3a plus 15 plus 4, and then we can combine like terms. So we're at 3a plus 19. That's as simplified as it gets, so that's going to be our answer. Here we have two different functions. H of x is equal to 5 minus x, and j of x is equal to 5 over x plus 2. So first, let's find j of 10. So here we're not even going to look at h of x. We only care about j at the x value of 10. So we've got 5 over, our x value was 10 plus 2. 10 plus 2 is 12, and this fraction cannot be simplified, so we're just going to leave it at that. In part B, now we only care about the h function, so anywhere we see x, we're going to put negative 12. So we've got 5 minus negative 12, but when you have minus and negative, that means you're going to add those two values together. So now we have 5 plus 12, which is 17. Finally, we have h of 4 minus j of 3. So first we're going to find out what h of 4 is, then we'll find out what j of 3 is, and then we'll just subtract those two values. H of 4 would be 5 minus 4, which is 1. J of 3 would be 5 over 3 plus 2. 3 plus 2 is 5, and 5 over 5 is 1. So now h of 4 minus j of 3 would be 1 minus 1, which is 0.